Simplifying square roots. So first off, let's just talk about what it means to have something squared. So 3 squared is 3 times 3, which is 9. Square root of 15 is 15 times 15, which is 225. So when you're taking the square root, it is going backwards. We're trying to figure out what number would have been squared in order to create that. So we're going to use something I call an upside down division sign to help us as we are trying to figure out the square roots of different ones. It's important to remember your prime numbers. Prime numbers are numbers that are divisible by only 1 in themselves as we go through these. So let's take the square root of 625. If I divide that by 2, it won't go in evenly. And 3 is the same thing. The next prime number is 5, so I'm going to divide by 5. If I divide 625 divided by 5, I end up with 125. So I'm going to do the same thing again. Divide by 5, and I'm left with 25. And 25 divided by 5 is 5. And so my goal is to look for sets of 2 of the prime numbers I divided by. So I have one set of 2, then I have another set of 2. And I'm going to write them down one at a time. So 5 times 5, which is 25. And this is one where I could have actually taken the square root of 625 and come up with 25 without any problems. But not always is that the case. So let's take the square root of 150. And so let's look at this. We're going to do our upside down division again. So 150. Well, this is an even number, so I know it's divisible by 2. Divide it by 2 and I end up with 75. Divide by, this time, it's no longer even, so I'm going to try 3. Well, there are 3 25s and 75s, so I divide by 3. Let's do it again. Well, this time I know 5 times 5 is 25. And so the goal is to get to where it's only primes on the outside. And then look for sets. Well, I have a set of 5s. So I write down that 5. What is left over goes underneath the square root, which is called a radical. And so we have the 2 times 3 under that square root.
Sorry, we're interrupting your video.
Okay, and so we have 5 on the outside, and under the radical we end up with 2 times 3, which is 6. This is our final answer. Because there's nothing in 6 that can be brought out of the square root. There's no sets of numbers that are exactly the same. So that's our answer. So sometimes there will actually already be a number in front. And that number in front will just be multiplied by anything that we bring out. So let's look at 495. And let's do our upside down division. I want you to pause it and see if you can do it on your own. Check to see if your answers matched what I have factored out. So in this case, we have a set of 3s that can come out. And then we're left with a 5 times 11 inside. So I'm going to multiply my negative 3 that I originally had times that set of 3s that I pulled out. And so that 3 goes here. Then we have what's left under the square root, and that would be the 5 times 11. So our final answer is negative 9 times the square root of 55. And I know that my square root is done whenever there's nothing more I can pull out. Let's see if you can do this one on your own. Pause it and see if it matches up with my upside down division. And then pause again to see if you did the factoring correct. So you should have ended up with one set of 2s and one set of 5s. And then you would have ended up with a 2 and a 7 that didn't have any pairs. So let's look at these and let's take each one individually. So we have the negative sign, and I'm just going to call it a -1 from the original problem. Then we bring out a set of 2's that we found in our factoring. Then we bring out a set of 5's from our factoring. Then what's underneath our square root is that 2 times 7. So when we combine this all together, we multiply -1 times 2 times 5, which is -10. And what's left under the square root is a 14.